When it comes to treating high-salinity brines, technology selection depends on the chemical composition of the brine, its salts, organics, silica, and more. The right technology turns that challenge into a manageable, often reusable water stream. In this video, we explain when to choose RO, when EDR is the better fit, and where evaporation and crystallization can close that loop.
Condorchem Enviro Solutions.
Reverse osmosis is the first choice for many industrial brines. It removes the bulk of dissolved salts with low energy use compared to thermal systems. With good pretreatment, RO delivers high-quality permeate suitable for utilities or as a pre-polished step for process reuse. As the brine gets saltier, the pressure required increases, eventually hitting a physical limit due to osmotic pressure. That's why reverse osmosis systems can only treat brines up to a certain concentration, typically below 70,000 ppm of TDS. If fouling or silica becomes the limiting factor, it's often more economical to hand the concentration to EDR or a thermal step rather than forcing higher RO recovery. Electrolysis reversal, or EDR, uses an electric field to pull dissolved salts ion by ion through selective membranes. EDR handles higher TDS levels than RO, and it tolerates organics that would traditionally foul membranes. It's useful for moderate desalting and non-potable reuse targets, especially when silica, iron, or organics challenge the RO. Energy use depends on how much salt needs to be removed. For modest reductions, EDR can be competitive and provide stable operation. When the objective is very high recovery or when membranes reach their limit, vacuum evaporation provides a robust solution. Evaporation tolerates dissolved salts, silica, and many organics that limit membranes. Foaming and volatiles are managed with proper design and accessories. The trade-off is a higher energy demand, but for challenging or zero liquid discharge applications, it's the only viable solution. Operating under vacuum lowers the boiling point of the feed so we can separate a clean distillate from a high concentrated brine. Distillate is typically suitable for utilities reuse and can feed higher purity step. Crystallization converts the remaining brine into solid salts. Permeate can be reused, while solids leave the site as a manageable waste, and in some cases, specific salts can be recovered for potential value. So how do you choose? Well, it depends on your brine's profile. Reverse osmosis offers the most energy efficient option for moderate TDS and low organic. In presence of higher TDS or fouling prone compounds, EDR brings more tolerance and flexibility. Evaporation excels for extreme concentrations or complex chemistry. Most high recovery systems are hybrids. 3 patterns cover many cases. The first, reverse osmosis to evaporation. Start with a low energy desalting and hand the final brine to the evaporator. Good when a feed is moderately clean and the goal is high overall recovery at a balanced OPEX. Number 2. EDR through to reverse osmosis to evaporation. We use the EDR to handle silica or difficult fouling, then RO for deeper salt removal, and finish with evaporation. This is useful for variable feeds where RO alone would require heavy chemical control. Number 3 is a physical chemical or ultrafiltration through to evaporation and then a crystallizer. We apply directly thermal systems when solvents, surfactants, or very high salinity limit membranes. Add crystallization for ZLD, or when landfill economics favor solids. Well-designed hybrids minimize total cost by letting each technology operate where it is the strongest. The right process should balance performance, durability, and a total cost of ownership. At Condorchem Enviro Solutions, we have extensive and proven experience in brine management. Our speciality, of course, is evaporation and crystallization, integrated with the right pretreatment and membranes for a reliable long-term OPEX.
Condorchem Enviro Solutions.